Today we are going to solve problem on a Lagrange's mean value theorem. The question is prove that a is less than 1, b is less than 1 and the condition given is 0 is less than a and less than b. Then we have to prove this. Let's start. If the given condition is fx is continuous on 0, 1, it is continuous on 0, 1, so fx is equal to sine inverse x. The given function is sine inverse function, right? Okay, then sine f to the power n is always continuous, right? Sine fn is always continuous function. Now second we have to move to the differential part. Let's check is it differentiable or not. Take f of x is equal to sine inverse x. Now differentiate with respect to x. Differentiate with respect to x. F dash of x 1 by 1 minus x square under root, right? F of x is differentiable on 0, 1. Hence the both conditions are true. Let's write it down. Both conditions of LMVT satisfied, right? Then f dash of c is equal to f of b minus f of a by b minus a is the formula to find out the LMVT theorem, right? Now write f dash of c value. As you can see, f dash of x is equal to 1 by under root 1 minus x square. So we can write f dash of c as 1 by under root 1 minus c square. And the f of b can be written as sine inverse b, right? And f of a can be written as sine inverse a. As we have seen earlier, here we can write f of b minus f of a by b minus a. Now we have the values of f of b and f of a. We can substitute in this. F dash of c is equal to 1 by under root 1 minus c square is equal to sine inverse b minus sine inverse a by b minus a. This is our basic equation we got from our formula. Okay, now we have the inequality. We have the condition of inequality a is less than b. As a is less than b, we can say that a is less than c and c is less than b, right? This will be the condition. Okay, a is less than c and c is less than b. Now we have to solve this inequality. So consider this equation. We are solving this equation, right? According to this equation we have to move. See the inequalities, how we can solve it. Okay, let's square this because we have square here under the denominator here, right? First square it. Squaring, right? A square, c square and b square. We did squaring here for this equation. Next, move to multiplying by minus 1. Why? Because we have minus 1 beside a square, right? Multiplying by minus 1. So what will be the inequality? C square minus b square. This will be the inequality for the next step. Next, what we have? We have 1. So add 1. Simply you can write these steps. Add by 1. Okay, let's plus 1, because if no operator is given, we should think it as plus 1. Okay, write it as 1 minus a square, 1 minus c square, 1 minus b square. Next what we have? See, we have square root. Let's take a square root. Take a square root. 1 minus a square, 1 minus c square, and 1 minus b square. Okay, what we have next then? Here we have it in denominator, so divide by 1, so it should come under this downwards. So divide by 1. 1 by 1 minus a square, 1 by 1 minus c square, and 1 by 1 minus b square. From equation 1 we could solve this, right? Now take from equation 1 we can write it as 1 by 1 minus a square sine inverse b minus sine inverse a by b minus a, right? And less than 1 by under root 1 minus b square. Okay, here what we can write at the position of 1, we can divide it as like this, right? So I will write it as b minus a by 1 minus a square sine inverse b minus sine inverse a by under root 1 minus b square. Here let's suppose divide by b minus a. So here we will get b minus a. Here we will get b minus a by b minus a. So these and these will be get cancelled. So the remaining answer will be b minus a 1 minus a square sine inverse b minus sine inverse a by 1 by 1 minus b square. Hence proved.